Hi, everyone. We are live again in a new session in the Entity Intelligence open source library. In the last session, we basically started putting together the implementation, writing a test for a service that its main role will be basically to convert an existing incoming input into a query, right? Into a natural query. And here it is. Hey, Kalu, how are you doing?
Good.
Okay. Do you have your stuff ready, or should I kick off?
I need less than 5 minutes to
Okay.
set up the station.
Okay. Set yourself up while I'm just kind of kicking the ball a little bit. So anyway, so let's just go back to what we started, right? We basically went and said, I need to build something that will generate data for me. And this, I don't know if this is over 120 characters. This is 110. Yeah, I guess we're okay. So we need something that will generate a dictionary of dictionaries, right? And this dictionary of dictionaries, what it's basically going to be doing is to give me like the equivalent of a table. And inside that table, there is data type and a column name, right? So a column name and a data type, and we need to convert that into the equivalent. So what's a test for this look like? So let me just go ahead in here. Since the method that we're working with is called a retrieve SQL query, and let's say why this guy is tripping. Did we change anything in here? So it's value task string like that, and maybe I'm missing a reference. Yeah, how did this guy ever build? That's a $1 million question. So let me just rebuild everything. Yeah, everything should be okay here. And then let's just get started with writing a test here. So it's a retrieve SQL query, right? So I want to write a class in here. I'm going to say AI processing service tests dot logic dot retrieve dot cs. So okay, so that's just going to nicely nest right under this piece in here. And then I'm going to make this partial. All of these, because they are test classes, they need to be public. No problem with that. Control KE will clean up the namespaces that we don't need. And then we're going to write a test in here. So here's a fact, public async task should retrieve SQL query async. Okay, here's the part where it gets a little bit fun, right? So let's break this into the threes and threes. So there's a given, a when, and a then, like that. And here's my random data. So it's a string of a dictionary of dictionaries, like that, right? So this is random table data. And here is generate a random table. This should be generate random tables, right? So this is random tables like that, right? So let's go back here, generate random tables like that. So why is this guy complaining? Because it's a list. Oh yeah, that's right. It's a list of a dictionary of dictionaries. That's crazy. So here you go, something like that. Okay, so this is random tables data like that. Cool. Now, for each and every one of these, we need to basically generate two different sets of things. The result, the final result that we expect to come out. The result, basically the query that will be passed to AI. But also we need to generate the input out of these results. So let's just start with one of them at least, right? So we can go and say, how complicated do we want to get here? Let's just do, here's a list. So what we expect to be passed to us is a list of tables. That's the input, right? So this is a table. What did we call it, guys? Let's see. So we called it a table information. That's right. So table information, right? And this is going to be random table information, random table informations, right? And let's go here and say, okay, so here's random table data, select. So I'm converting, right? And this is table data like that. Ideally, I want to return a list of table information, and we're going to need that mapping in a second. But okay, if that's the case, then I need to return something in here. We'll hold that for a second. And in every piece, like in every iteration of these, we need to do another iteration internally, right? So I'm going to create a table information. So var table information equals, right, new table information. And then inside that guy, I should have, let's see here, I should have the table name, right? So that's table data dot key, I think. Right, so why is this guy giving me keys? Because it's a bunch of tables and I'm iterating. The dictionary is a bunch of tables, so I don't think we need the list anymore, actually, because the dictionary is a bunch of keys already as it is. So why do we need a list in here? We don't. We actually don't. So maybe I tried to wrap up quicker. So let's go back here. Yeah, this list here is not needed at all. At all. Dictionary like that. Right, so if this guy is giving me a dictionary of something, this is just a, let's see here, instead of having this guy return a dictionary of one item like this, we can just have it return a tuple of, yeah, that makes sense. So that will be a tuple of a string and a dictionary, which means I just need to go back here and just say return, right, I think new, something like that, and that should take care of it. So that's a tuple there of the table name and the column dictionary. Yeah. So now that I have this random number that I have here, I could just go up in here and say for int I equals 0 and table count, and then I basically have my final dictionary here, which is var all tables or tables dictionary. New dictionary of string, whatever. And then now inside of that, I can go and say, keep iterating for that count and give me back for each one of these. Okay, that makes sense to me at least. So let's do it this way. This is gonna basically take that tuple and add in a key and a value in there. Yeah, that's right. So, okay, so tables dictionary dot add, right? And I have here my tuple, so I can do something like this: string table name and dictionary of string table data. And that guy is already deconstructed, so I just need to generate a random table in here, and that will give me that good stuff automatically. And now all I have to do is just say table name in here and just table data like that. And then I could just return the tables dictionary. So this is deconstruction that's happening on the fly. And I'm basically taking the table name and the table data and adding it to this final dictionary after I've already generated a random number like that. Okay. Hey, Zia, how are you? Salam. And hey, Gregory. Okay, so now that I have this data, I can basically go back into my test and I can make things a little bit more interesting like that. So let's go here. There you go. And then I can, yeah, I can iterate here much better because now I can basically go and say for each key in random table data, right? And the key will be a string since the right side is not clear. What is this key supposed to be? Let's see. Oh, key value pair of a string dictionary. Oh, that's why they didn't. Okay, I want this to be explicit though. There you go. So that's my key in this table data. And each one of these key, yeah, so that's right. Or I can even do better. I can say string, and then this is table data.keys. So what's the type of this keys in here? What's your type, buddy? Just a key collection, which I'm assuming is a list. My collection, yeah, something like that. Yeah, that's much better like that. So, So, okay, I want to generate out of this stuff. Can I do a mapping on this? That would be perfect, because that would be basically be what I want to accomplish. So let me do that. And let me just say, let's see here. This is a list of table information. This is random table informations, like that. And then keys.select. Oh yeah, I can do that. So key like that. And somehow I need to map this into table information one way or another. So we know now that this key that I'm iterating on for each and every one of these, that's the table name. So the name here is basically the key, each and one of these tables, right? And then underneath that, there are columns, and that's whatever is nested underneath that key, right? So I need a new list. We need a list of columns, right? So this will be table column. So that will be random table data of the key, and then the values, select, right? And this table, and then we need to return .to list of table columns, like that. Somehow, whatever comes back from this thing, right? So what's really inside of this thing? Each and every one of these should return a new table column, and this table column will have a name and a value, right? So that would be table dot what's your type, buddy? You are a string, right? So that's, oh yeah, because you're iterating on the values, I'm assuming. So okay, if I say table data, so these values are supposed to be key value pairs. So I'm doing a selection, so that's a table. But why the table is a string? It should be, if these are values, it should be a key value pair. Something is missing. Let's
But
see.
you're going through the keys on line 23, right? So you're one level down.
Yeah, this is the table, right? So the table of the key and then dot values, right? So on that key, there's a value, and these values is a dictionary. So I'm iterating on a dictionary here, I think, right? Unless there is a, let's see here, let's do it old school. So I'm gonna go back here and say, okay, let's do it this way. So this, let me do I have keys in here? So that's the key on that internal dictionary in here, right? And it is a key value pair. Yeah, so this will be table. So now what is the value of this? It should have a string. That's right. So that's the table column key. That's this guy. And in here, we still need the data type, which would be the table, the random table key, this guy here, dot values of that table key, table column key, like that. It should be something like that, because this guy is a dictionary. Like these values are dictionaries, right? It's a value collection, right? Because it has that. Oh, I wonder if I could just do this. Hold on. Yeah, there you go. Because it's a dictionary of dictionaries. Hey, Amir Khan. Okay, so that should do the trick for me, because that basically is saying, give me that dictionary. Well, now let's just see, why is this guy tripping? Because it needs to return that guy, right? So this is return. There you go, return table information, and that needs to be, and then we broke everything, which is super fun. And then we're just gonna say dot to list like that. So now I just generated the input, right? Let's verify. Is that really true? I'm gonna put an assert true here just to hold things up. And I'm gonna run this, Control RT. Let's see what it's, oh, because I said partial, and so this needs to be public as well. Let's go back here, debug. Yeah, there you go. So what is inside this guy? Let's see here. So if I do quick watch, oh, it doesn't show it here, but it's beautiful. So if I add watch in here, you can really see every table. So here's a table name, and inside that table there are 3 columns, and every column has a name and a type, and they are different from each other, which is great. It's all garbage data, but it's generated, which is really what we're trying to do here. Cool. So far, so good. Sweet and simple. Something very, very, very similar to that is what we're going to need to do to basically, so this is the input. We generated that input from that random table's data. But that's not the end of the path, because we still need to go, well, first of all, I'm just going to go here and say table information, input table information equal random, so just to kind of fix the language here. And I guess it doesn't need that anymore because it's smart and all. So here you go, and simplify this a little bit. Okay. Now the next step is that we want to go and say string expected natural query. That's the query that we're going to be passing in to this guy. This is where it gets fun, because what we're going to need to do here is to basically take that exact iteration here, but turn all of this into a string, right? And it's not going to match the business logic because we're working from this common model that we're working with here, right? So how are we going to do that, right? So I'm assuming we could just also pick up this exact same guy here for a second, and then we need to think through how we're going to do that. So we know that there is a key in here that we're pulling out of this. So I'm gonna comment this part for a second. So we're basically saying select for each one of these. We basically just need to kind of be able to go and say for table X or table X has the following columns, right? And we basically start listing each and every column in table X, right? So if that's the key that we're generating on, then we basically need to start appending that somehow, right? It's probably, at least for the stringification kind of aspect of it, I don't know if select is going to help us a lot unless we turn it into a string array and then just kind of concatenate all of it in one shot. We could probably do that, don't we? So I can go here and say return out of that select. Let's see here, just to kind of, exemplify what I'm trying to say. If I have a string X, right, and I say enumerable range from 0 to 10, select, right, and this is your item, and I'm basically saying for each and every one of these, just give me the item back dot to string or whatever. And then I want to concatenate all that, so I can basically go and say to array, but at the top of this, I basically say string dot concat, something like that, or what was it? There is a
The join.
Thanks, that's the one. Join. So the separator is just a space, and we're basically going and saying something like this. So that should do the trick. So if I do here, so X, what's inside of X? 0, 1, 2, 3. So it's going to be something very similar to that. Right. So the idea here is that we at the end of the day, we still need to return a string. Whatever that string may be, that's the trick. I think it's going to be really easy to do that. So here's the trick. So this is the table name, right? So we're going to go and say and here's your string table query, right? So that's my table query. We're going to get to that part in a second. But the table name here would be basically the key. We already know that, right? And then all columns and types, all columns, types, right? And we basically go and say, give me that guy, all of this here, right? And I want to go and say for every column key, return it will be the column key itself, which is a table column key, and then say with type, and then put that guy in there. Okay, we got all of these done. Great. Now let's put this in an array and basically concatenate that. So it's basically string dot join, give them a space here, and then basically between each one and the next, and basically something like that. Right, we're gonna clean it up in a second, but this is our working solution. We make it work and then make it right, and then we're gonna make it pretty. It's the rule. So something like that. Okay, so this guy's doing the concatenation. Now I can actually go and say, well, these are the columns. Then I can go here and say return. The final return is basically table query. It will be for table name with columns, and then basically you put all column types like that. And then we're gonna need to flatten that out as well. Like that in and of itself, it needs to be flattened out too. So this will be .toArray. I wonder if it just works nice, if it plays nice without having to kind of convert to an array. We're gonna discover that in a second. So that's this guy, and then all of that goes down to here. Right? So that's of course super ugly. We're gonna need to kind of simplify it a little bit, but let's just see if it works. Does it actually work at all? I don't know. Let's find out. So I'm gonna put a breakpoint here, and then I'm gonna run the debugger. And then check it out. So the expected natural query, I'm gonna put that on a watch like this. And here's my watch. I don't think you guys can see the output because it's in a different window, but that's basically the output. Let me show it to you here. So look for table blah with columns, this with type that, and then this with type that, and then this with type that, and it should keep going like that until it reaches the next table, and then the next table, and then the next table, and so on and so forth. Pretty straightforward, right? Any questions about that part? Of course, it's weird because it's random data, right? And it's intentionally random so we can prevent anyone to try to kind of play the test. Okay, but that's not the end of the road, right? Because the query that we have in the POC basically says, let's go back here. Really, the query that we have in the POC is not that. It's this in addition to some other details. Let's go back to the POC and just see what I put in there, because what I put in there works. And then we're going to optimize that stuff really, really soon. So let's go around. Here's entity intelligence POC. And here is I think it's something in here. Yeah, it basically says entity name has the following properties, right? And then at the very top in here, I basically went and said, let me open this like a normal human being. This is a weird view. So I said for entity name, and then go ahead. This is property as that, right? Okay, so how did I concatenate this? I basically went and said, translate the following into a SQL query, right? Respond only with code given SQL DB with the following tables. And then I started saying, here's my full query. Full query is getting here. So this here is basically saying, yeah, so entity name blah has the following properties, and so on and so forth. Okay, let's do that then. So our expected query then would be something similar to this. Let's do that. There we go. So this is here, all tables, columns, right? So this will be random tables and columns, right? So I have these, and the one change is, for table blah, we basically said, yeah, for it has the following, right? So table name, right, has the following columns, basically, right? So table name has the following columns, but that's not it, because here we want our expected natural query. It would say something very, very different. Well, it'll incorporate that part, but it needs to say something on top of that. So it will say respond only with code given a SQL DB with the following tables, right? And then it goes on to basically concatenate, right, the random table columns like that, right? And then once I have done that, now I have to say translate the following request into SQL query. So that's the other part. So in here, we need a random, so here's string, random natural query. This will be get random string or generate random string. We need to change this to get random string. Or yeah, it's create random string. Yeah, so input random, input natural query. So that's your random natural query. And then that input is what needs to be baked into that guy. Okay. In addition to all of this, we also want to go here and say string random response, random AI SQL response. And this is a generated string. And then this is AI returned AI SQL response. So that will be the random AI SQL response here. And then the last one is expected AI SQL response, which would be the returned, like that. Cool. Okay, so if that's the case here, now we're getting really close. Now I can set up our mock then. So I can go here and say mock setup service, and then service dot prompt query. And here's my expected natural query input, right? And we don't have to do anything with it is as or anything like that because it's a string. So they're keeping the exact same the memory reference, right? So this guy will say returns asynchronously, and this is the returned AI SQL response. Okay, so this is actual AI SQL response. Await this dot service, so it's our processing service. Retrieve SQL async. Where's my input tables, input table information, and here's my input natural query. Okay, that means the actual AI should be equivalent to expected AI response. And my mock, my service mock should be called proper with the right stuff. So this will be prompt expected input times once. That's right. like that. And then the last thing here would be just our mock should be verified to be called only once. That's it. See, doing things the right way will take time. Questions, comments? Are we clear? Does it work though? I don't know. It should fail, right? So we should go here. Kylo, are you ready? Are you in the mood for it? Can you do it in 20 minutes? Let's see.
I got the easy part.
Oh yeah, I guarantee you that part is the easy part. I'm actually glad you were a little bit late so I could just go through this. I know you could do it even faster, but you know, you were late, so you missed the fun. Okay, so let me run the cleanup here real quick, okay, and then I'll give you the horn. You can have it. Wow, that's wild. Okay, so here's that thing that was WIP. Now it's a fail. It's a proper fail because it's saying the method is not implemented. So it's an actual failure, not because something in our randomization didn't work out. It's mainly because, you know, the data that we've put in didn't match, or the expectations didn't match. All right, okay, go to time. Okay, go to town. You got it.
Okay.
Here we go. Yeah, it should be the processing SQL 1K.
Okay. Let's see. Okay.
Let me know if you need ideas.
Okay.
So while Kailo's working on this, Omar brought up an interesting topic. He basically said, you know, this was in our standard community Discord channel. Let's see here. He basically said, you know, regarding exception, it does seem like the standard emphasizes a very important role of exceptions, which is why we're, oh yeah, so that's back to the, you know, question about, you know, just mandating, right, Omar, mandating that all of them have a message or have a message and an inner exception, and you can't have any overload, you know, or override for the constructor. So that's, I guess, I talked to Christo about this, and he basically said, before he went on vacation, and he basically said, I don't mind the assertion part, but I wish that we didn't have to do that. I wish there was a way that we can tightly ensure that, you know, just based on the models, because in a way, I feel like we're testing our models, right? Do I want to test my model, my data carrier? Not really. I don't want to test my data carrier. So it's an interesting problem, and that's why I like anemic models, because the properties you put in are the properties you get out. You will see me rarely use constructors for anemic models, because a constructor is this hybrid between data and behavior, and there's no guarantee. You'll see some people even check for nulls in their constructor and throw null exception in the constructor. It's wild, right? So I think, really genuinely, I think our best option here is to find out a way to instantiate an exception as an anemic model. And it does sound and seem insane, but that's the way to do it. I don't know how yet, but that's the way to do it. We need to instantiate our exceptions with properties that we can pass a set, a get set properties, and then somehow some magic needs to happen underneath to map that to the exception model. How that's going to work, I don't know. That's basically the answer, Omar, if you're listening still with us. So I don't know, man. All right, going back to Kailu here. So yeah, you're getting your inputs as tables and then natural query. Yep. Yep. Yeah, if you do select on this and basically take the table, yeah, do select, take the table, extract the name, and then there's a list of columns underneath it. That's exactly what it's going to be. Yeah, open up a scope here, okay? It's going to make it easier for you this way. Yep. And then you're going to basically need, so just instantiate a string, just call it table name. So that's table.name. And then no, that's a semi because you're in a scope. And then instantiate another string and just call it table columns. In the top here, call it table name columns, table names columns or something like that. So you don't kind of conflict because you have two variables with the same name or something like that. Line 25. Oh, you called it tables. Okay, yeah, sure. Yeah, perfect. So the same thing. You're gonna do a select, and then you're gonna do a string join here, and that would be it. So do a select on the table.columns. Say line 28. Now call it a column, and then and then return a string. Just do a $sign double quotes because it's a function. It's a fat arrow function. And then you're basically gonna say, here's my column with type blah and so on. Just like line 55 in the file below. Yep. Column.name, right? Notice it's with type, not with the type. Just saving you a couple hours of debugging there. Yep. So this is column.type. Now you need to do string.join, just like I did. So on line 28 after the equal sign, 28, well, 29 now, do string.join.
This one, right?
Uppercase S, yeah, string.join, and then put a space there, and then double quotes space, yep, and then comma, and then close that. That should do the trick for you. Yep. Now you have that stringified, right? Now you can concatenate the table name and the table column.
Okay. this, we're kind of doing two things at once.
Yep.
Right? So we
Yep.
normally don't do that. Okay. Just
We
think.
should probably break it apart. I agree. I'm all in cleaning this a little bit because especially this double quotes that we're passing in, it doesn't have a parameter name, so that kind of sucks. We should probably clean that, but let's just see if we can get it to work.
Shit, it's literally copy paste from the test, right?
Literally. Yep. It's very straightforward.
I wonder if this data is, for example, in JSON format, will it perform better for the large language, the LLM, basically? Because it's kind of more crisp, right? Like this is a table name, these are the columns in JSON. It's formatted properly.
Do a POC and tell me.
Yeah.
Do a POC. Pull that POC and tell me if that works.
Did you notice any problems with your normal like strings?
Nope.
Yeah. Okay. Yeah.
Yep, you can close that one. But I think, by the way, Omar, I think your approach is very clean. I like it. It's just about how much it's going to cost, how much that's going to cost, but also in terms of tokens and what does it mean in terms of AI understanding it. I'm all game with you. I think it's a great idea. I
It will
actually think
cost
it's
more for sure. Like it will cost more because of the JSON
because you're adding
attributes
yeah,
and traces and stuff. Yeah.
yep. Because you're adding all the parentheses, squiggly brackets, all the double quotes. It's gonna come heavy, right? So, but I do think from a programming standpoint, it's way cleaner. I agree with you. I actually haven't thought about that. I like it. We like it a lot.
Yeah, we'll try it and see how.
I have a feeling it could even make AI much less error prone than if we just give it like a flat thing with just a bunch of. No, I'm with you, man. I think it's a genius idea. I like it, Omar. See, brother's smart. He knows. He got the stuff. All right, Kay. I think that should do it.
Okay. We definitely want to simplify this.
Oh yeah.
We're doing two things at once here. At this, we're doing
Yeah, that's ridiculous.
5 things at once.
Yep. This is just getting it to work. You know,
Yeah.
we're gonna need to make it right, and then we need to make it pretty. Look, it passed. Oh wait, it failed. So why did it fail? It says, oh, that's not right.
Somewhere it's on that.
So let's see here. Column, you did do column name. You did do column type. And then you basically said table name. Where's your natural query coming from?
Natural query, it's from.
This is gonna be a string thing because it's saying null, right? So that basically means that did your call actually come back with what you're expecting? You know what I mean? So just make sure that your string query really matches what you're expecting here. So let's see, respond only with code, given a SQL DB with the following tables, and then you put a space there, and then random table name columns, yeah. Translate, we should say translate, not translated, but translated the following request into SQL query. And then you have table name colon has the following columns. Yeah, I told you, man, take that. You have that type. I told you, just take away that type. Why did you writing that type in there? Line 31. that type, you see, THE.
Gee,
Yeah, take that out. There's no
don't have
there's no that. It's with type. Yeah.
why did I have
Yeah, run it again. Still?
Okay.
There you go.
Works now.
Magic, right? By the way, 80% of debugging is just skills about catching the differences. Like, you know, notice the difference. Omar says YAML is cheaper than JSON, but is it cheaper than the natural query? That's the question, Omar, because you're only working with a limited number of tokens, at least for the time being. Ali says, hi Hassan, yesterday you've mentioned about many people attempt to do something similar. Why they give up is the token limit. And after that, you said, I have my solution or workarounds. Yeah, I have a couple of solutions actually. One of them is the offline model, but the other solution, Ali, is to parse the query, the natural query, and only target the tables that this query is talking about. So instead of feeding the entire model every single table, you know, if I basically have 3 tables, courses and teachers and students, and my natural query says, give me all the students that have their name Ali, right? So why would I feed AI about the teachers and the courses, right? That's the optimization mechanism, but we're not there yet. We still have to get everything settled first, and then we add the optimization on top of it. Does that make sense to you? Like there's the offline model, so we're not limited by the tokens at all, but that's just like a brute force solution, right? We could think about this as an entertaining problem, as an engineering problem. If we still want to go with OpenAI, we just need to filter only the tables that make sense towards that query, that natural query that's coming in. That's the trick. It's a very easy trick, but it works. It won't work 100% of the time, but maybe 90% or 80% of the time, which is good enough for an open source project that we're trying to do. It's all right. Offline models, okay, that's a hard process to determine. Yeah, the problem with offline models too is that they're very heavy. I can't ship an offline model with a NuGet package. It's gonna be like tons of gigabytes. You're also limited by the it's going to be a lot of gigabytes unless you host that offline model in an API that's yours, and you basically go and say, okay, my API is open with no limitation on the token level. That's another option that you may have. And then Ali also said, but parsing solution is hard to determine. Yeah, it is hard, but if we can solve for that problem, like, let me ask you this. We can still hit AI itself and tell it, hey, here's the table names that we have. Even if you have like 100 table names, it's not going to consume all your 4,000 tokens. It's going to be still lesser. Like, you're hitting AI and you're saying which one of these tables are relevant to this natural query. And then you filter these tables and then you go send it back to AI and say, given these following tables with these following columns information, you know, how do I write a query, a SQL query for that? So it would be 2 calls, right? About 25 pennies each, but it would definitely do the trick. There's a bunch of optimization options that we're gonna have to explore. Ideally, the acceptance criteria for this is to build a table that has 100 tables, and each table has 20 columns, and say this is my acceptance criteria. So 20 columns, 100 tables, hit the AI, and if it works, then we have a good product. And then we can go build the desktop application, which is going to be the easiest, probably the easiest project I've done on a stream in a long time. Good questions, though. So, okay, you made it pass. It's all good.
Yeah.
Okay, take some time and clean it up, and then tomorrow we can do. Tomorrow is what, Wednesday? Yeah, tomorrow Wednesday we meet. I might be out on Thursday, but I'll definitely be back on Friday. So just take some time and clean it up. and push that, and let's have maybe we could have Omar do the validations tomorrow. I will write validation, tests, and it's a very easy validation, right? So it's null, empty, or white space for the natural query, right? And the table information can't be null, and we need to examine each and every column inside of that table information. Oh, it's going to be an interesting. It's going to be an interesting validation process, because we have to go through that list and make sure every piece of it makes sense. All right, Kay, it's all yours now. So just clean it up a little bit and push towards that draft PR that we have. I don't know if we created a draft PR for it. Let me just double check here and make sure while you're doing that cleanup. Here's GitHub. So here's entity intelligence. And then, yeah, we didn't create a draft for it. So this is processings, retrieve SQL query. And we want, let's see, the label here will be processings. Thanks, Gregory, for setting that up for us. This is pretty cool. Where is it? Processings, integrations, foundations, design data. Do we not have processings? Hold on. Process. Okay, cool. Let me create one. Processings. And just give it something and go back here. Create that PR. And then here's a label, processings. There you go. Cool. And this is draft. So, and this should close. We don't have an issue for it. I wonder if Milan is good with this. So processings, retrieve SQL query. Here's the label, processings. Like that. And then here's an issue. Let's go back to the PR. And let me just say closes that. Okay. All right. That's it for today. Thank you all for joining in. Kailu, take your time to just make this look right, and then we'll look at it again tomorrow. Okay, friends. Thank you all for joining in today, and I'll see you tomorrow. Take care. Bye.